Good morning, students.
Good morning, madam.
Good morning, ma'am.
Good morning. We have discussed 3 units from digital design and HDL. So almost we have completed first section of your syllabus. Okay. Now we are going to start with a new unit. Okay. Now, if you look at your syllabus, the fourth unit is state machines. Okay. And the fifth unit, that is the testing circuits for digital logic design. Okay. So actually, instead of starting fourth unit, I'm going to start with the fifth unit. Okay. Because I want whenever we are going to start state machine unit, that time I want direct interaction, and I hope that till we complete your fourth and fifth unit, we may meet at college level. Okay. So I hope, I pray to God, so we can meet earlier. And then uh, so now we are going to start with the fifth unit. Okay. So I'll share my screen. So let us start with our fifth unit, that is testing of logic circuits. Okay. So here what we are going to study? We are going to study different testing circuits, okay, which are or different testing techniques which are used to test logic circuits. Okay. So the content in this unit, that are testing combinational and sequential logic. Okay. So various methods which are used to test combinational as well as sequential logic, that we are going to study. Then after that we are going to study about one testing technique, that is a boundary scan. Then built-in self-test. Okay. So these are the testing techniques that we are going to study. And after that we are going to have knowledge about test bench for combinational design, for binary adder, then comparator, then encoder, decoder, multiplexer, and demultiplexer. Okay. So for these simple combinational circuits, we are going to write a test bench. Okay. So these are the contents in this unit. So you can write down this. Completed.
No, ma'am.
Okay.
Completed, ma'am.
So now we'll see which books are to be referred for this unit. So the first book, that is a Fundamentals of Digital Logic Design with VHDL by Brown and Brancic, which is published by McGraw-Hill. Okay, so the second edition that can be used for this unit. Okay, and the second book that we are going to use, that is a Digital System Design using VHDL by Charles Roth. Okay, so that is published by Cengage Learning Publication, and again the second edition that could be used for this topic. Okay, so these are the two books from which we are going to study about this fifth unit, that is a testing of logic design. Okay, so now let us see what is why this title of this chapter, that is a testing of logic design. Okay, because in this unit you will understand why testing of logic circuit that is important. Okay, and after that this title also suggests that in this unit you will learn different testing methods of digital logic circuits. Okay, so here we are going to study about different testing methods like a boundary scan, then BEAST, that is a built-in self-test. So that we are going to study in this test. Also, we are going to study about a stuck-in model faults. So that we are going to study in this unit. Okay. So write down about title of the chapter. Shall I proceed?
Just 1 minute, ma'am. Ma'am, completed.
Okay. Then central idea of this chapter, as we know that a fault, which is also referred to a physical defect in a circuit. Okay, so when we are considering a fault which is related to a circuit, so that means it is a physical defect. Okay, and it is necessary to verify that the design circuit meets the required functional as well as timing specifications. Okay, so that means whatever specifications for which we are designing any circuit, that should be completely met and that should be verified by the designer. Okay, and so this central idea of this unit is to provide introduction of different digital system testing methods, which will make the system easier to test. Okay, so though if there is any defect or the fault that is present in your design, then you should know certain methods which will be used for testing of that circuit. Okay, and that is why we are going to learn about this unit. Okay, so write down central idea of chapter: a fault which is also referred to a physical defect in a circuit. It is necessary to verify that the design circuit meets the required functional and timing specifications. So, central idea of this unit is to provide introduction introduction to different digital system testing methods that make the system that make the system easier to test easier to test. Then let us see what is the importance of this chapter. This chapter introduces different fault models and various testing techniques. So, to study whether output meets desired specifications or not using different testing techniques, this unit is important. Okay. So, as from this unit, you will understand what are the different types of faults and then how to test that faults and uh, get to know whether we are meeting desired specifications or not. Okay. So, for that, this unit is important. So, write down importance of chapter. This chapter this chapter introduces different fault models different fault models and various testing techniques and various testing techniques to study whether whether output meets desired desired specifications or not using different testing techniques using different testing techniques. This unit is important. This unit is important. So the chapter outcomes are the first is explain different fault models. So at the end of this chapter, you will be able to explain different fault models. Then second one, that is explain different testing techniques like boundary scan, then built-in self-test. So like that testing techniques that you will be able to explain. And the third one, that is you will be able to write test bench for different combinational circuits like binary adder, then comparator, encoder, decoder, multiplexer. So for all these combinational circuits, you will be able to write test bench. Okay. So these are the chapter outcomes of this chapter, testing of logic design. Till now you must have got idea that in this unit we are going to study about different fault models and then how to test whether there is a fault or not. Okay, so different testing techniques that we are going to study in this unit. Okay, so let us start with the actual uh, uh, topic. Okay, so but before starting with that actual contents, let us again one more time revise what is VLSI development process. Okay, so whenever we are developing any chip, we have to go through different steps. Okay, so the first step, that is a system specification. After that we go for architectural design, then functional design and logic design. Then after that there is a circuit design. Once circuit design is completed, then physical design. After that there is a physical verification and sign up, and then the chip is fabricated. Okay, so that means once we get the specification, from that we need to go through these different steps, and after that there is a fabrication. And once this chip is fabricated, there is a packaging of, that means that circuit is fabricated, there is a packaging of that uh, chip, and then testing of that. And then you get the finalized result, that is the IC or whatever chip that you have designed. Okay, so that is, these are the different steps when we are going for the development of any circuit. Okay, so let us discuss about this process. So whatever are the specifications that are given by the customer or whatever is the project need. Okay, so if you are going for any system, so for the need of for that system, you need to have uh, any VLSI device that need to be fabricated. Okay, and so for that you will get certain design specifications. So a VLSI device requirement is determined and then formulated as a design specifications. Now once you get these design specifications, designer synthesize a circuit that satisfies the design specification, and then it verifies the design. Okay, so that means it is the second step where there is a architectural design is there. Okay, so um, here uh, designer that will synthesize a circuit. That means first of all he will write a HDL code for that design, and after that he will simulate, then synthesize that, and then he will check whether it satisfies the design specifications or not. Once design specifications are met, then design verification, that is a predictive analysis, that is done. Okay, so that ensures that synthesized design that will perform the required functions when manufactured. That means whatever specifications that you have made, now once it is manufactured, it will perform like that only. Okay, so whatever, for what specifications you have designed any IC, so depending on that only it will work. Now if suppose there is any error in a design, then modifications to the designs that are necessary. Okay, so that means suppose we find any error in the our design, so we need to modify that design, and then again design verification that should be done. Okay, so if there is any error, so we need to modify and then again verify whatever design is there. After that, this VLSI design is ready to fabricate. Okay, so once verification, physical verification that is done, we go for the VLSI design, and at the same time, the test engineers that develop a test procedure that is based on design specification and fault models associated with that implementation technology. So here now the task of test engineer starts. Okay, so work for the test engineer that starts from this step, that they need to now develop a certain procedure. Okay, so whatever circuit that we have designed, for that which type of testing circuit or testing procedure that is suitable, depending on that they will develop certain technique, and then they will test for that circuit. Okay, then the chips that pass the wafer level test that are extracted and packaged. So this, if the ICs that pass this test, then after that they are extracted and then packaged, and then these packaged devices that are retested to eliminate those devices that can be that may have been damaged. Excuse, they may have been damaged during the packaging process or put into defective packages. Okay, so that means uh, once we have designed or extracted the chip, after that we need to package. But once we have the packaging, that means it may be metal can package or plastic package, so depending on that, that wafers that are packaged. Okay, now again it may be dual in line package, or circular, that is uh, another type of packaging that may be there. So depending on that, that are packaged. But once these ICs that are packaged, after that it is once again tested, so that uh, it may not have any damaged ICs in that. Okay, and then additional quality assurance that is tested. Testing is used to assure the final quality before going to market. So when it go to the market, it is made sure that whatever ICs that are present in the market, that are all in a well condition. That means there is no any fault present in that ICs. Okay, so this is the actual VLSI development process. That means what we are doing, we are ensuring that whatever product is going in the market, that is free of any uh, free of any faults, or it need not any uh, modification that is required. Okay, so that means uh, it is ready to work, it is having a desired specification that are fulfilled with that IC. Okay, so this is overall VLSI development process. Now let us see. Now as we have discussed here, so let us see what is the actual need of testing circuits. So there are various reasons for the testing of logic circuit. Now suppose when the circuit is first developed, it is necessary to verify that this circuit meets desired specifications. Uh, that means it may be functional specification or timing specification. Okay, so for which function we have designed that circuit, it should meet that specification, as well as timing specifications. That means delay that are present, that should be in such a way that it should be properly working condition. Okay, again, suppose we are making multiple copies of our design. Okay, so when multiple copies are manufactured, uh, it is essential to test each copy to ensure that the manufacturing process has not introduced any flaws. Okay, so that is another reason for the testing of logic circuit. Now, whenever you were doing practicals of digital techniques, you must have faced certain problems like one IC is working in a proper condition and another one is not working in a proper condition. Okay, so that means you are not getting desired result even though the IC is new. Okay, so that type of problem you must have faced because this is because of the manufacturing process flaws. Okay, so that means these are the faults that are encountered while manufacturing process. Though a design was proper, but still because of the manufacturing process, there are certain flaws that are present. So, this testing process that can become very expensive and time consuming. So here, as we require all the copies that to be tested, so this testing process that becomes very expensive as well as it is a time consuming. And with today's complex ICs, so as we are going for so much of the complicated circuits, so complex ICs, cost of this testing is a major component of manufacturing cost. So this is the main thing which is added to the manufacturing cost, and therefore it is very important to develop efficient methods of testing of digital circuits, and to design systems so that they are easy to test. Yes. So it is required that we have to know efficient methods for the testing of this digital circuit. So the basis of all testing techniques is to apply predefined set of inputs. Okay. So whenever we are going for any testing technique, we are going for the applying certain inputs, okay, which are called as a test to a circuit, and then compare the outputs that are observed with the patterns that a correctly functioning circuit is supposed to produce. ओके, म्हणजेच आपण इथे काय करतो की प्रत्येक सर्किटला आपण इनपुट एक प्री डिफाईन्ड इनपुट देतो. ओके, दॅट इज कॉल्ड एज अ टेस्ट. त्याला आपण टेस्ट असं म्हणतो. आणि त्याच्यानंतर जर सर्किट करेक्ट असतं तर त्यानं काय आउटपुट दिलं असतं त्याच्याबरोबर आत्ताच्या येणाऱ्या टेस्ट इनपुट दिल्यानंतरचं जे काही आउटपुट आहे त्याच्याशी कम्पेअर करतो. अँड देन वी डिसाइड दॅट whether it is in a proper condition or not. Okay, that means it is functioning well or not, that is decided. So the challenge is to derive a relatively small number of tests that provide an adequate indication that the circuit is correct. So this is the challenge for the test engineers. So whenever you are going for the complex circuit, it should have a small number of tests which will give the indication that the circuit is correct or not. Okay, and so here there are very much opportunities for the test engineers in the core field. Okay, so where we can develop different test techniques. Okay, so if we look for the basic testing approach, as I said earlier, so we give certain a test input, that is the input test stimuli to the circuit under the test. Okay, so it is given as an input, this vector or whatever is the test signal that is given to the circuit under test, and after that we are getting certain outputs. Okay, these outputs that are compared with the correct outputs, and then it is decided whether that circuit is passed or failed. Okay, so this is the actual basic testing approach for the any digital circuit. Now let us see different testing techniques. Okay, so Depending on which type of circuit we are testing, there are two types. Okay, so the combinational circuit testing and sequential circuit testing. Okay, as we know that in a combinational circuit there is no any feedback from the output. Okay, because we are not using any type of output uh, as an input to the circuit. Okay, so output of combinational circuit, that is dependent only on the present condition. Okay, present input condition. So here we have three different types for the combinational circuit testing. One is the fault model, then another one that is a path sensitizing, and third one that is a random test. Okay, so these are the three methods for combinational circuit test. And in a sequential circuit testing, as you know that we need to have a feedback. That means output is dependent on the previous state output also. So here we have certain different test methods. So the first method for this is a scan path test. Then another one that is a built-in self test, that is a BIST, where we have again two types, that is a built-in logic block observer, that is a BBLO, and signature analyzer. So these are the two tests which comes under built-in self test, and then boundary scan test, that is a BST. So these are the different tests that we are going to study in this unit. Okay. So is there any doubt till now?
No, ma'am.
Okay. So why we are going for testing? Because we want to make sure that whatever circuit that we are going to be in a market, that should be correct and properly working. त्यांनी सगळे जे काही स्पेसिफिकेशन्स आहेत ते मीट केले पाहिजेत आणि तेवढ्यासाठी आपण मार्केटमध्ये ते आपलं प्रोडक्ट लॉन्च करण्याच्या आधी वी नीड टू टेस्ट इट, अँड फॉर दॅट वी नीड टू हॅव सर्टन testing circuit. Okay, so now we are going to check for the first method which is used for combinational logic design. Okay, so fault models. A circuit functions incorrectly when there is something wrong with it. Okay, so that means suppose we have a transistor. Okay, as you know that we use a transistor while manufacturing these IC. Suppose that while manufacturing, that transistor is at fault, or suppose there is interconnection wiring is at also fault level. Then what will happen? That circuit will function incorrectly. Okay, it will not give proper result. So a transistor switch can break so that it is permanently either closed or open. So if we are using transistor as a switch, and then if it is break in such a way that it is continuously in a open condition or in a closed condition, that means we will get the input to next circuitry as either high logic or as a zero logic, and so that because of that it may happen that we will get wrong results. Okay, then if we have a wire, that means we have the interconnections, all these transistors that are connected through the wire internally, and for that interconnection, suppose that wire is shorted to VDD. Okay, so that means a logic 1 level. Okay, it is continuously connected to logic high level, or it is continuously connected to ground, that is a logic 0 level. Then what will happen? It will obviously give wrong result, because suppose we are using AND gate, and one of the input terminal of AND gate is connected to logic high level only. Okay, continuously it is connected to logic high level. What will happen? For the AND gate, suppose one of the input is continuously connected to logic high level. Whether it will make much difference?
No, ma'am.
No. But if suppose that, okay, but still it may result in a something wrong, but still it will not be visible. But suppose that input is connected to logic 0. Now what will happen? अँड गेटचं एक इनपुट कंटिन्युअसली झिरोला कनेक्ट केलं असेल, काय होणार आहे?
Output became
दुसऱ्या टर्मिनलला जरी तुमचं 1 असेल, ओके, तरी तुमचं आउटपुट हे काय जाणार आहे? 0 जाणार आहे. ओके, सो दॅट मीन्स वॉट एव्हर मे बी द इनपुट लेवल्स देन, इफ may result in a wrong. Okay, so that is the reason that you will get wrong result. So, or it may happen, that means your wire that is continuously connected to VDD or ground, or it may happen that it is completely broken up. Okay, so that means there is no any connection internally that is present, and it may happen. So you must have seen sometimes on your PCB that track is broken. Okay, so that means there is no any connection, or whenever you are building any circuit on a breadboard, बऱ्याचदा तुमचं असं झालं असेल की तुम्ही चुकीच्या होलमध्ये तुमची वायर इन्सर्ट केली आणि त्यामुळे कनेक्शनच नाही झालं, मग आउटपुट येत नाहीये. अँड यू स्पेंड आवर्स ऑन थिंकिंग दॅट why my output is not coming. So this type of things that happens. Okay, so while manufacturing also it may happen that that wire is broken and then you are not getting proper result. So again there can be an unwanted connection between two wires. So it besides all the problems that I have discussed earlier, म्हणजे ट्रान्झिस्टर ब्रेक असेल किंवा तुमचे कनेक्शन काहीतरी रॉंग झालेले आहेत, VDD लाच कनेक्ट होऊन बसलंय, ग्राउंडला कनेक्ट झालंय, किंवा कम्प्लिटली ब्रेक कनेक्शन झालं, याच्या पलीकडे असंही होऊ शकतं की दॅट देर इज अ अनवॉन्टेड कनेक्शन बिटवीन टू वायर्स. ओके, अँड बिकॉज ऑफ दॅट it is getting certain another signal instead of the actual signal. Okay? So fortunately it is possible to restrict the testing process to become to some simple faults and obtain generally satisfactory results. Okay, so there are certain simple tests with which we can test that circuits, and then we can get satisfactory results for that fault model. Okay, so let us see what is the different types of faults now. So the first here fault is stuck at model. Okay, so that means whatever as we discussed now that there may be certain faults, and one of the faults that is called as a stuck at model. Okay, so a good model for representing faults is to assume that all faults manifest themselves as some wires and being permanently stuck at logic value 0 or 1. Okay, so that means whenever we are considering any stuck at model type of fault, so that means that the logic at that wire is permanently stuck at logic 0 or logic 1, which is also called as a stuck at 0 or stuck at 1. Okay, so suppose we are considering a wire W. If W has an undesirable signal that always corresponds to a logic value 0, then we say that W is stuck at 0. Okay, and it is denoted by W slash 0. Okay, so this is a one type of fault where your wire is continuously or permanently connected to 0 logic level, and we call it as a stuck at 0. Or suppose that wire W that is continuously connected to logic 1, then we call it that type of fault that is a stuck at 1, and which is denoted by W slash 1. Okay, so these are the two stuck at models. One is stuck at 0 and another one that is stuck at 1. Now a circuit can have either a single fault or possibly many faults. Okay, now it may happen that if you are using different inputs at the same time, different logic gates that are present, so there may be possibility that there are different faults that are present, okay, or many faults that are present in the that circuitry. So dealing with the multiple faults is difficult because each fault can occur in many different ways. So the practical approach is to consider single fault only. So here whenever there are many faults that are present, so that time it becomes little bit difficult to understand what type of fault it is. But if it is a single fault, then this type of method, that is easy. The test method that we are going to use for this type of fault, that is becomes easier. So now let us say have one example. Okay, so single stuck at fault. Suppose here now you can see that here there are this combinational circuit. It has three inputs, A, B and C. Okay, but here you can find that this B signal, that means actually these are the inputs, and here where it is connected to that D signal or D wire, it is stuck at 1. Okay, that means this wire is continuously connected to or permanently connected to logic 1. Okay, here also this logic wire E, that is permanently connected to 1 logic level, that means this is also stuck at 1, and output of this OR gate is permanently connected to logic 0, that means it is stuck at 0. Okay, so we have three faults. Okay, each of the wire has only one fault, that is it is stuck at 1, this is stuck at 1, this is also stuck at 1, and this one is stuck at 0. So these are the three faults in overall these three circuits. Now what should be the actual output of this circuit? Y is equal to, what should be output of this circuit? Correct output of this circuit in terms of input. What is the Boolean expression for the output? Just look at the circuit. What is Y? Y is nothing but ORing of output of this AND gate and this OR gate. Okay, so that means output of this AND gate is a and B. Okay, and output of this OR gate is a B plus C. That means here Y is equal to A and B plus B plus C. Okay, so that means ORing of this operation. Now here actual output, that is a Y that is equal to AB plus B plus C. Now here if you look at the circuit diagram again, this is stuck at 1. Okay, this is also stuck at 1. Okay, now we will consider only one problem right now. Suppose that we are considering these stuck at 1. Okay, so that means B will be always having value R, whatever may be the logic level present at B, that is input we are giving to give. But as this wire is stuck at 1, that means the logic level present at this input terminal, that will be always at a high logic level. Okay, that means depending on the input A, output will get decided. कारण आपलं इथं जर D आहे, इथं 1 आहे, म्हणजे इथं जर A 1 असेल तर आपल्याला आउटपुट हाय मिळेल. Okay, if A is 0, then output will be 0. At the same time, for this OR gate, as this is stuck at 1, that means whatever may be the value of C, output will be always equal to 1 of this OR gate. And as this OR gate's output is 1, so therefore Y will be always equal to 1, even though whatever may be the conditions or state of this all input. Okay, are you getting this point? Now here you can see that output when as
Excuse me,
B
ma'am.
is, yes,
Ma'am, screen नाही दिसत आहे.
wait a minute, I have lost internet connection, so wait a minute. I hope now it is visible.
Yes, ma'am, it is visible.
So, all of you understood? What will happen if D is stuck at 1? Y will be continuously equal to 1. Okay. Now, if suppose E is stuck at 1. Okay. So, what will happen? Now, as E is stuck at 1, that means here, whatever will be the B output, B input, that will be present. But at this input terminal of AND gate, it will be logic high. So output will of this AND gate will be equal to A, while this OR gate will be equal to B plus C. And that is why Y will be equal to A plus B plus C. Actually, it should work as a AB plus B plus C. But now it will work as A plus B plus C. Now, if suppose this is stuck at 0, okay. Now what will happen? Okay. These are working properly. Now we are considering only one fault at a time. So these are working properly. But now this F is stuck at 0. That means this wire is connected at a 0 logic level. What will be output? What is the actual output of the circuit? Y is equal to AB plus B plus C. But now B plus is C is going to be 0. That means Y will be equal to AB only. Okay. So here this output Y, that will be equal to AB only. That means because of these faults, you will not get proper output. So here, this is the way. Actually, now here we are going to find or that there is a output. So as we are applying certain input and depend as we are not getting actual output, so we can decide, we can come to the conclusion that there is certain fault at the circuit. Okay. So now let us have certain testing for AND gate and OR gate for the stuck at point. Okay. So here we have OR gate and AND gate, which are 3 input gates. Okay. So first of all, we will consider that this AND gate. Okay. Which has 3 inputs A, B and C. Okay. So here now suppose there is a fault at A input, that is it is stuck at 0. So now how to test whether it is stuck at 0 or 1? So for that what we do? We apply 111 input to all the input terminals of this AND gate. Now if all the input terminals are at 1, okay, what should be actual output? If it is correct, okay. If the circuit, the gate is correct, then if we are applying all the input terminals at high logic level, what should be output? तुमचा output काय यायला पाहिजे? सगळे इनपुट टर्मिनल जर 1 ला आहेत तर तुमचं AND गेटचं आउटपुट काय पाहिजे?
जर 1 1 असतील तर 1.
1 यायला पाहिजे. दिस इज द करेक्ट आउटपुट. बरोबर आहे ना? की जर माझे सगळे अँड गेट तुम्ही डेफिनेशनच असं म्हणता ना की जेव्हा सगळे इनपुट 1 असतील तेव्हा आउटपुट काय असणार आहे? 1 असणार आहे. ऑर अदरवाइज इफ एनी वन ऑफ द इनपुट इज 0, आउटपुट इज गोइंग टू बी 0. बरोबर आहे? आता याच्यामध्ये या केसमध्ये जर माझे सगळे इनपुट 1 असताना माझं आउटपुट करेक्ट इनपुट 1 येत असेल, यायला पाहिजे. पण जर या इनपुट टर्मिनल्स मध्ये एक जरी टर्मिनल 0 ला स्टक असेल, म्हणजे 0 ला कनेक्ट झाला असेल बाय परमनंटली, तर काय होणार आहे? जरी मी इनपुट 1 1 1 दिले तरी मला आउटपुट काय मिळणार आहे? 0 मिळेल. बरोबर आहे? So that means though I am giving the input in all the inputs of high logic level, if any one of the input terminals is at 0 logic level, then I will get output that is equal to 0. That means now we can decide that actual output should be 1, but now I am getting 0 output. That means there is certain fault at that gate. Okay. Now we want to test now. Okay. Which of the input terminal is at another logic level? Okay. So suppose now we will consider another case that any one of the input terminal is stuck at 1. Okay. So that time we of the input terminal is stuck at 1. So that we want to find out. Okay. Now here we can consider in this case, that means stuck at 0 level, we can decide that this gate is not properly working, and then we have to discard that. Okay. That design. Okay. Now here, if suppose any one of the input terminal for the AND gate, it is stuck at 1. So that time, what you can do to test whether it is working properly or not, give only one input at the logic 0 level. Okay. So here and other input, keep it at a high logic level and check for the output. Okay. So from that, you can decide whether that input is stuck at 1 or not. Now suppose A input is stuck at 1 logic level. Though you are, and then you are giving logic 0 to A input, logic 1 to B and C. Now if these are at a correct logic level, but only here A is stuck at 1. So that means though you are giving logic 0 as an input, you will get output that is equal to 1. And from that you can decide that this input terminal is stuck at 1. Okay. So similarly you can do it for the other input terminals. So from this you can decide that whether this circuit is at the fault, that is stuck at fault or not. Okay. That is logic stuck at 0 or stuck at 1 fault. Now similarly you can do this for OR gate also. For OR gate now, you can check it for whether any of the input terminal is stuck at 1 or not. For that, what you can do, you can give an input 0, 0, 0 at all the input terminals. Now, whenever you are giving in all the input terminals at a 0 logic level, that time for a OR gate, correct output should be 0 only. But if any one of the input is at logic 1, then what will happen? Output of that OR gate, that will become as a 1. Okay. So if any one of the input terminal is stuck at 1, wrongly the output of that OR gate will become as a 1, and then you can find out that there is a stuck at fault. Stuck at 1 fault is present. Okay. Suppose you want to find out whether any of the input terminal is at stuck at 0. So for that, what you can do, keep other input terminals at a 0 logic level and only one input terminal at a high logic level. Okay. So the correct output in that case should be 1. But if that input terminal is stuck at 0, then wrongly you will get the output that is equal to 0, and that hence you can decide that that input terminal is stuck at 0 logic level. Okay. So this is the testing method for stuck at fault. Okay. All of you understood this?
Yes, ma'am.
Okay. So we will discuss next part in the next lecture. Okay. So for today we will stop here. Okay. You can leave this meeting and join for the next lecture.